Hi, I'd like to share something that I learned recently. Um, uh, I've been working with Tensorflow for a little bit over a year, on and off, just for until I, give up, and then I retry again a few months later. But I was really um, uh, focused on working on reinforcement learning with Tensorflow, um, and I really want to get it working on stock trading, or get it kind of working. Um, but I got to take baby steps, because every time I work towards the stock trading, um, I, I realize how complicated it's going to be, and then I give up. And so I wanted to start with baby steps. So I started with tic-tac-toe. Um, and I didn't know how complicated even just making tic-tac-toe would work. So making the game was pretty easy. Um, uh, it wasn't too bad. And then, I thought, wow, it takes a long time just to play tic-tac-toe, because I would just input um, coordinates, so like 0, 0 to go into the middle. Um, and so it would take a long time just to play the game. And I'm thinking, I don't have enough time to play tic-tac-toe, to teach my algorithm, or teach my model how to play. So I made a random number generator, which is also pretty easy, just to play the game for me, and it plays it so much faster. Um, and then, so I have two number generators, the random number generators, playing against each other for the first uh, couple of iterations, I guess you could say. And I value the board, the current board. I do some math to, if there's two in a row, it's more valuable than if there was one in a row, right? Or if there's just one hanging by itself. Or if there's two in a row with an empty space is more valuable than no empty space, because there's potential of winning. And then also, if you've got two in a row and your opponent has two in a row, then whoever's turn it is, their value is higher, because they have the potential to win, and kick your ass. So anyways, so that's how I value it. And so I have a model that learned how to value the board, right? And it's a pretty small model. So I play about 100,000 games, and then I teach my model how to value the board, and then or the critic. I teach the critic, and then I start teaching I play another 100,000 games about, and then I start teaching the actor, and the actor actually plays the game, and actually I have the critic feed into the actor, so I've got a few layers for the actor. I've got the current board, the previous board, whether it's X's or O's. So if it's X's, it gets all ones on a layer, and then if it's O's, it gets negative ones on that layer. And then I also have the value layer, which I added pretty recently, but that comes from the critic. I just predict using the critic, and then create a whole layer out of that one value. And so this is a 4 by 3 by 3 input for my actor. So it gets pretty big. So with this, I guess you could say, program, it was working, right? but it's working really slowly. I've got it written down here. So when it would randomly play, it would only get the prediction for teaching the actor, right? So that gameplay would take about 0.062 seconds per game, right? So from start to finish, a game would take 6/100ths of a second, right? Not that bad, but I would have it update me every 1,000 games that, 1,000 games have occurred. And it would take 60 seconds for that to happen. So in the long run, or if you look at that 6/100ths of a second, that's not that long, right? That's actually pretty fast. But if you're playing hundreds of thousands of games, that takes like an hour to play 100,000 games. So that was just taking a long time, and then when it actually take the critic and then feed that into the model, oh, it would take forever. It would take a quarter of a second per game, and so that would be like 9 minutes per. At this point, I started playing 50,000. Oh, sorry, my bad. It would take 9 minutes to play 1,000 games, right? Am I right? Sure. Okay, it would take 4 minutes per 100,000 games, or I mean per 1,000 games. My bad. And so it would just take a long time for it to learn something. And I was struggling on trying to make it run much faster. Um, I actually tried to play 10 games at once, uh, and then synchronize them all so that I can predict using my critic at the same time, and then play a little bit more, and then it was getting really complicated, pretty much. Um, and so if I tried to make like a batch of, you know, a batch of inputs, and then get a batch of outputs back out, and then continue playing. So it was starting to get really complicated, and I'm racking my brain, and down on my luck and everything, and I'm just frustrated, right? And so I'm looking at the TensorFlow um, uh, document to figure out if there's another way to predict that is faster, right? And so I'm reading this, and I know it works on batches, the dot predict function. And then I see for small amounts of inputs that fit in one batch, call your model and then your inputs. And I'm thinking, no way it's that easy. And so, I just try it out. So this is the current iteration of my code. Let's see if I can find it. It's pretty long. It's like almost 700 lines. Okay, here's one. So here's when I make a move. It usually always takes a prediction with the critic model, and I took out the dot predict. And so when I'm just using that one right there during my random state, so I randomly play the game. The actor is not acting right now. Um, it takes 0.0056 seconds per game. And so 1,000 games would take about 4 seconds. So this is what it used to take with the dot predict. And then this is what it takes without the dot predict. So it's about 11 times faster. Not too bad. Instead of 60 seconds, per, or sorry, what was it? Zero. Okay, yeah, it'd take 60 seconds per 1,000 games, whereas this other one would take about 4 seconds per game. Yeah, 5 seconds. Sometimes they take 4 seconds. I just took a number. But it kept getting faster, right? So when it would sometimes use the actor and sometimes play randomly, it would take about a quarter of a second. And that was, what's a quarter of a second times? Okay, it would take about 4 minutes for 1,000 games to play. Okay, the same step, pretty much, where it plays some random and some with the actor. It took 15 seconds, 16 seconds per 1,000 games. So that's about 15 times faster. Just changing a dot predict to no dot predict. And then I would always have to convert it into a NumPy, because it would always give me a tensor, an eager tensor, I believe. And I've been using NumPy arrays as my outputs. So yeah, I hope it's pretty useful, because it was definitely useful for me. I could teach my tic-tac-toe models in just like an hour or two, whereas before I would probably think with the dot predict it would take a couple days to teach it how to play tic-tac-toe at all, or at any level, pretty much. And the slowest that I found this model with no dot predict was half as fast as my fastest dot predict. So the slowest I found it was about 0.03 seconds per game. But this is when it's heavily reliant on the model. So it's mostly always using the predict, and sometimes randomly playing. And so it'd take 30 seconds for 1,000 games. But that's alright, because that's the slowest it's been. Um, so, yeah, I hope that this was helpful for you, and I didn't ramble too much. Thank you.